Hello and welcome to the SAS Global Forum 2020 for our virtual webinar. Today, myself, David White, Tim Howard, and Snow Lopes will be presenting our paper, Achieving Net Zero Forecasting Power Usage to Improve Sustainability on Clemson University's Campus. Specifically, we're going to be speaking to our effort under the Clemson Energy Visualization and Analytics Center, where we are working to improve sustainability on campus, primarily focused on data, analytics, and visualization using SAS technology. And with that, I'm going to pass off the presentation start to Snow Lopes.
Hi. My name is Snow Lopez. I'm Clemson Energy Engineer and System Analytics. Just want to give you a brief scope of our Clemson campus. So we are about 26,000 student population and about 5,000 to 6,000 staff population. So about 32,000 population campus we serve. And we have about 6 types of energy services across the campus: electric, steam, seawater, water, wastewater, and natural gas. So on Clemson campus, we have various distribution networks. One of there are primary steam water, chill water, and electric distributions are key distribution networks. Just give a brief overview of steam distribution network. We got about 7 boilers ranging from 9,000 pound-hour to 78,000 pound-hour steam. We got 100% redundancy in our steam distribution system. We got 1 CHP heat recovery steam system and a generator with 75,000 pounds per hour through that heat recovery steam generation. And our campus peak demand or peak steam load is about 110,000 pounds per hour. And for cooling system, we use chill water as a primary centralized district chill water distribution system. We got about 5 chill water systems, chill water plants on campus with a loop capacity of 16,500 tons. And our peak summer load are about 11,000 tons of chill water. And just to give you how that tons are, is your average U.S. household is of 2,000 to 3,000 square feet just require 3 to 4 tons HVAC system. And this research paper, we are primarily focusing on electric distribution. So our campus electric distribution is served from one Duke Energy substation, which is 28 megawatt substation. And in 2012-13, our campus load exceeded 24 megawatt of peak demand. And you can see throughout after 2020-13, we got a significant growth on campus. And now our demand load is very close to 35 megawatt during the peak summer load. And to maintain this campus infrastructure, we use Schneider Electric SCADA system. But one thing we are always doing is monitoring every single building. So every single building, so we take electricity on one location at one Duke substation. And then we have our own infrastructure to deliver to all our buildings. It's roughly about 200 buildings. And all that building, we do have metering. We do have sub-metering at some location, but we closely monitor our power through all the meters on every single building. To connect all this infrastructure, metering infrastructure, all our campus chill water, HVAC, every whole infrastructure, we use Johnson Control Metasys as our primary BAS. BAS stand for Building Automation System. Metasys primarily use BACnet protocol, but we have some Modbus TCP for our electric meter usage. So we run all of infrastructure on a campus network, and everything come together as a connected system through our central repository and then to various SCADA systems. And here, just give you an example. We have our chiller plants and boilers connecting to Metasys and goes to network NC is what we call, and those all sensors and everything. Primary, it comes to our campus Ethernet fiber and goes to our main repository and our main SCADA system and BAS system for controls and all of the verifications. And at CEVAC, we are trying to pull that data from all our BAS and all our SCADA systems to various protocols. So here, you can see all our data we are pulling together for CEVAC. We got about 4.5 billion records in our facilities data set for a year. That's only a year worth of data. And then we are pulling that to building automation BAS API or ODBC connectors. We are creating a central database for our whole energy and utility infrastructure. And then that's 4.5 billion records. And our system is we are kind of so imagine a giant tank, and then we are filling small different tanks. So a system we have created called pipelines. So every pipeline will fill data to a usable data set, which we want, like say watt power, or watt center CO2, or watt center time. So we are creating that whole infrastructure to pull and automate data integration between various buildings, various type of utilities, and so on. So you can see facilities data. We are pulling that data to XREF and in Historian data sets from BAS to SAS. And there are two primary things in our data sets, facilities data sets. One is Historian and one is real-time, latest. So Historian data sets we are pulling from one location, and then on latest data set we are pulling through API. And then we're going to combine that two data sets for our further analytics. Why we are doing this? So we have net zero reduction goals. We have commitment for better sustainability and climate CO2 reduction. So we, as a large campus, we got about 8 million square feet of conditioned space on campus, which is, and the electricity we use is about 30,000 US households. So it's a big impact on our carbon footprint, a global carbon footprint. So we want to reduce, we want to become a net zero campus. So we have a commitment. So how we're going to achieve those commitments is through this data and data analytics. The first thing we want to make sure is we have visibility to our user. Hey, well, how they are doing, how much carbon footprint, how much energy they are using. Where are we in terms of other institutes or other people? So we want to give them visibility. Then we want to create tools for efficiency and clean energy, like how we can reduce energy, how we can do efficient energy practices, how we can do some performance contracts. So those are the things we can get out of this data analytics. Then we want to do a carbon neutrality. So we want to plan for future, how we're going to achieve. So we have a goal of net zero by, right now we have 2030, but how are we going to go there? What are the steps we have to take? And that's what we want to do with the second goal of our efficiency and clean energy. And the third thing we want to do is the health. We have a commitment to for our user is a healthy Clemson, a healthy campus. And every user spends about 40 hours a week in the building. So we want to make sure that we give them a right, healthy indoor air quality. So we want to do some analytics with indoor air quality. So those are our primary goal with CEVAC energy scope.
So I'm going to provide some background on how CEVAC got started here at Clemson. And it really started here. It started at the Watt Family Innovation Center. This is a state-of-the-art building on the Clemson campus. It was opened for business a few years ago, and it is loaded with technology with the goal of really providing an environment for collaboration among students, faculty, and business and government. It's envisioned as an aggregation point for all kinds of ideas and essentially an opportunity to start programs, initiate opportunities, and have those spawn out of the Watt Center and move on to further funding and bigger opportunities. And CEVAC itself started with what really, seemed like at the time a simple question: what makes a building smart? The Watt Center was, as it was being opened, was considered a smart building in many ways, but it also was much like some other buildings in that a lot of those technologies weren't connected, and there wasn't a lot of automation. And we're still not quite there yet, but we are making progress on that front. But when you start thinking about smart buildings, what are those core requirements? And one is sensing. You need a lot of sensors in a smart building. And so as we started to dig into the data sources that were available to us, we began to find that we had near real-time or historical data for every room in the Watt Center had a temperature, and we also had some humidity sensing. We had a lot of CO2 sensors in various rooms across the Watt Center. We worked with Clemson facilities with SNOL and began to deploy sub-metering. So not only did we have 1 meter for the Watt Center to measure power usage, but we were able to sub-meter the building so that we could get multiple measures of different components by each floor and by various systems. So for example, lighting versus outlets versus HVAC. Additionally, we are also beginning to monitor water usage in the building. And one of the big opportunities we also began to look at was occupancy. We'll talk a bit more about that later. Data, we found a lot of data. So for example, the Watt building, over its 2 or 3 years of operation, when we started to look at the data, had millions of data records. And the campus as a whole right now has over 4 billion records of data. Additionally, we started not only to look at those data sets or those data from the various sensing systems for the Watt Center, we started to bring in external data, one being weather forecast data and historical weather data. Additionally, we needed to build out an information technology, and this is where SAS really proved to be invaluable. We started working with SAS Data Integration Studio, which allowed us to essentially literally in one day connect to our campus data system and begin to design data pipelines to consume data. And not only were we able to build out these data pipelines using SAS Data Integration Studio, we're able to use that tool to set up cron jobs that then allow those data pools to be automated every hour, essentially. And so from there, after we built those data pipelines, we were able to push the data into SAS Visual Analytics, into the SAS Laser Server, and start to work with SAS Visual Analytics to visualize the data and really build out a seamless environment. And the SAS tools were really invaluable because at that time, it was really just Tim, myself, and Snow working on this, although now we do have a number of undergraduate and graduate students working on the project. And so, one of the driving goals of what we were going after here was to understand, what makes a building smart, but also to reduce carbon emissions at a campus and building level. And when we think about why that is important, Snow alluded to this earlier in the talk, And that is because building operations really account for an exceedingly large percentage of global carbon emissions. 28%, it's estimated, and that's actually a low estimate for carbon emissions for buildings worldwide. And when you throw in construction of buildings, that increases that footprint up to over 40%. And so how we build and manage our buildings and how we power and run our buildings is really important. And if we can just make single digit or even 5-10% differences on the Clemson campus on a building by building basis, that is going to make a huge difference. And that's one of our overarching goals. But when we start thinking about, some of the most advanced smart buildings out there, what are they? Well, if you do smart building, one of those that will come up most likely is the Edge, which is located in Amsterdam. So, for example, it has 28,000 sensors. It has web dashboards. It's known as one of the greenest, most efficient buildings in the world because it has solar panels supporting a lot of its energy generation, on-site energy generation. Additionally, when we start thinking about smart, it allows the user to customize their light and the temperature in their local space. And so there's a lot of technology in this building, and that's a direction that we'd like to see the campus, Clemson campus go, is that type of smart building technology. So where are we now? We've developed a platform to drive sustainability and improve efficiencies at a building and campus level that support interdisciplinary research. So it should be noted that, we are an academic institution. And so not only are we approaching this from a sustainability perspective, we also want to build out a foundation for research and also an educational opportunity. And this is also a partnership between the Watch Center and Clemson facilities. And we think this is a very unique partnership at a national level. And this facility, CEVAC, is staffed by a number of students working on information technologies, including database, middleware, visualization, and modeling, providing great opportunities for on-hands solving real-world problems. As I mentioned, this is a research and education platform. So from an education perspective, this allows students to work with other students from other disciplines, provides hands-on experience solving modern information technology challenges, and really making a sustainability impact. And I think that is one of the driving objectives of a number of our students, is that they're really concerned about global climate change and carbon reduction. And this gives them an opportunity to make an impact. And what are the potential opportunities for research? Big data, sensor development, real-time data processing, building system automation, sustainability, carbon footprint reduction, building efficiency, and just smart campus in general. There's a lot of opportunities out there with this type of platform that we're working on. So when we think about from an architecture and information technology standpoint, where is the CEVAC platform at this time? We're able to consume all kinds of different data sources, from regular databases, cloud-based APIs, over Wi-Fi networks, and all that data is streaming into our CEVAC databases, where, as Snow was talking about earlier, we primarily have historical and latest data sets. And from there, we've built out alert systems, our own APIs to share data, and set up tables that support our SAS visual analytics. And from there, we're able to generate real-time reports, alert emails, and also web pages. And I'm going to turn it over to Tim.
Oh, so we started looking at how can we look at the campus. So we created this interactive map where we could look at utilities and indoor air quality. We can get a rough guide of where we are across the campus. We decided to have a little bit of fun with the colors. So athletic buildings are kind of a browny, orangey color. The academic buildings are the purple, and then the living, housing, and dining are the green. So you can see just one clear shot here, where the buildings all fall within each other on the different things. Here we're showing temperature. So if you clicked on any one of those buildings, you would get to the dive here. We have about 12 dives right now for each of the 12 buildings that we have on campus that we're looking at. We're moving that into 35 by the end of this year. So here we wanted to have one dashboard to give an overview of the building now. The students felt it necessary to put in a picture of the building, just because some students are new and not so familiar with buildings on campus. Then we have the power, how much power is being used by the building. And then along the bottom there, you've got the steam, the chilled water, and the water. We wanted to have an idea of the outdoor temperature and humidity. And then looking across the building itself, what is the hottest room and the coldest room? Which room has the highest humidity? Which one has the lowest humidity? And then again with the CO2, which is the highest and which is the lowest CO2. And then along the bottom there, you'll see known issues. Those are issues where we found anomalies in the database or in the data. And we've researched it and we know what the issue was. Maybe it was a power outage, maybe it was a sensor that died. We write that down there so we don't have to keep looking for it every time we see that data. We know what's going on. In the middle there, we have alerts. Those are where we're starting to play with alerts to tell us if a room is getting too warm, or if the CO2 is getting too high, or if the sensor has stopped reporting, or in fact, if the CO2 is actually reporting too low. We found that some of the CO2 sensors, the good examples out in the bottom right there, you'll see the CO2 sensor is 136. That's since been fixed. It was an issue with the CO2 sensor needed to be recalibrated, so we spoke with facilities. They came in, recalibrated the sensor. And then the tickets, we're looking at all the tickets that are being created from the building to, those are tickets really to facilities or work, whether it's maintenance or whether it is for corrective action. We can begin to see what issues are going on, because that gives us an idea now. If we're working on something and we see a sensor going down, we can get a good understanding. Okay, so facilities have taken that down. Now we know what's going on. We've taken along the top there, you can see we've taken a lot of deeper dives in a number of things: temperature, CO2, power. Here I wanted to show you about the data rooms. Well, we've got an air handler here. It's a good example of a finding that we had. The temperature was about right. It was a little high, but it wasn't out of norm really for a data room, certainly a modern data room. But when we started looking at it further, we noticed that the air handler was working at 100%. That obviously was an issue. We put in a ticket, and facilities came and investigated, and they found that the air handler hadn't got the vents correctly positioned. We actually did a further investigation and found there were 2 other data rooms with the same problem. So they corrected it, and you can see obviously by this slide here when they did that, instead of working at 100%, this now air handler is now working at 56.7%, and the temperature is dead on now. So it's working really, really well. It's a good example of how these students use this data, researched it, worked together, worked with facilities, worked with the building operators to solve the problem. As Snow mentioned earlier, carbon footprint is a big deal for us. We're really trying to focus on that. So we really just started investigating. We're working with RMS, our engineering company, as well as facilities, to using standard calculations, figure out, or estimate at least, our carbon footprint for each of the buildings. And here you can see our carbon footprint as it's related to the energy usage. So chilled water, electricity, or steam. It's a good guide for us to be able to see. And obviously on the top, you can see we can do it by year. Okay,
so one of the opportunities that we've had and developed as we've been working on this project is measuring occupancy. And rather than relying upon a new deployment of occupancy sensors across buildings all across campus, we decided to try to leverage those technologies that we have on campus, we've settled at this time on using our wireless access points. Clemson has a great wireless infrastructure, and we are able to essentially data mine those wireless access logs and provide a 30-minute estimate of occupancy by floor in a building. And we're currently running this for the Watt Center and the campus library, which is a very large space. These two figures here that we're showing actually show visitor counts by day over a given time period, and kind of a hotspot analysis for time, telling us when the Watt Center is most busy. And so these data here are an aggregation of those 30-minute observations. We're really excited by this technology. Finally, our power forecasting tool. One of our goals has been to begin to develop a forecast model of power usage for every building that begins to enter into the CEVAC portfolio. Right now, the only one that we have is the Watt Center. We do have a student working on one for the library. So why are we interested in power forecasting? One, we're looking at how we can improve building efficiencies. It can lead to an understanding of how different buildings and HVAC systems perform when compared, among others, because all these buildings have been built at different times and have different infrastructure. And detect and diagnose building system faults. So, for example, that issue that Tim was just discussing, although that was a visual diagnostic, we envisioned that we might be able to use modeling to help us better understand building performance. And if a building is not performing at its expected performance, that may be an indication that we need to dive into that building a little bit more to identify where there might be issues. So we're using a deep learning neural network. This currently is not being run in SAS, it's being run in Python. The factors that we're using in that include total power consumption, the time of the month, the hour of the day, day of the week, cloud coverage. So we're bringing in cloud coverage and forecasted temperature and humidity. Additionally, we plan to move on to occupancy. And so right now what we have is we have a 24-hour forecast model. And in this model, in this slide here, the actual data usage is in red. The most accurate model at this time is probably the hybrid model scaler. That's in the kind of baby blue here. As you can see, for the most part, we're able to track trends pretty well, but we do miss weekends. That's the dip that you see here in the middle of this screenshot is a weekend observation where the building goes into no occupancy mode. So finally, what we wanted to talk about is another really exciting opportunity that we've been pursuing, and that's the idea of a CEVAC Virtual Operations Center. And so we've been working with a small company, and that company essentially has a model that allows us to build out a virtual operations center. And so what you see in these two slides are, one, in the background, we've taken the SAS Visual Analytics dashboards and essentially pasted them. And so as a viewer wearing virtual reality goggles, you step into this space and you can literally walk around the room and see all these dashboard slides. Now, unfortunately, at this time, these aren't real time, so we can't make these slices and paste them into the room in real time. But we can envision an opportunity that we could pursue that, where every hour we're updating this virtual operations center with all these visualizations. Secondly, in the second graphic here that we have on the right, not only do we have the background material in this operations center, but we have real-time data streaming into a table located in the center of the room. This data happens to be from our power forecasting model, where we're looking at total power usage and absolute air over time. And as a kind of a virtual user of this room, the concept is that you could have multiple people from on campus and from off campus, all leveraging this space to identify issues, to discuss opportunities, and just to experience this concept of a virtual operations center. And so we're really excited about where we've taken this technology up to this point. Here's our contact information. We thank you for your time. And you please reach out to me if you have any questions or suggestions. Look forward to hearing from you. Thank you.